Alright, first call of the day. Brand new install, less than a year old I think, so not much of a call here, but what I do on these ones is I commission them fully with a full Measurequick report and save it to the cloud so that next year when I go back I can reference it. So it is a full furnace maintenance. So what I'll look to do is, you know, there's not much cleaning that needs to be done on this thing. It's brand new. So a couple things is check, you know, my gas pressure. Sorry guys. Clock the, pretty much set my input. Make sure that the input's correct. Adjust my temp rise. Make sure it's, you know, mid-range on a high efficiency furnace. So good for efficiency, good for comfort. And then do my combustion test, make sure it's safe, and basically check everything. Send them the report, save it to the cloud, and I should be done in 45 minutes to an hour. So I'll see if I can get some footage on how that goes. It's probably a boring one, but whatever. Okay. So what we have here is a newly installed EL296 two-stage feed blower. And one thing I do notice right off the bat is I could tell that my ductwork, my static, is fairly high. So we'll check into that. First thing I'll do is I'll clean the sensor, even though it's new. So I like to test my unit right off the bat. Then any cleaning that needs to be done, I do that at the end, just to make sure safe operation, make sure that it's working and operational before we even bother cleaning it. I always check these because sometimes there's shavings inside. Make sure that these are free and clear, which they are. Okay. Get ready to check my gas pressure. 2 meters. This one needs new batteries, which I forgot to grab. And on these Lennox, this is how they want us to take the gas pressure. You want to tap into this burner box as well. here. Stick my probe in like that, which is good enough. Supply side. Looks like I got a little hole here. That'll do. This battery is charged, fully charged. Set up my static pressure holes. Just like that. This will be my supply side. One, I'll just go straight down here. It's my return side. Now I know they say to stick it into the airflow. In my experience, it's just static pressure. It's like pressure, so I really don't see any difference. But I'll do it like that. Perfect for holding in the button on the door. Alright, so now what I need to do is set up my Measurequick. Okay, so I'm going to go to my toolbox. I'm going to activate my probes. See that they connect. Zero my manometer, and both my supply and home have connected, which is good. I'll start this bad boy up. Positive side, negative side. Going to view the actual burners when they light, just to make sure they're okay, and then I'll put the plate back on so I can get proper reading on my pressure. At the same time, I will exit this project, create a new project, start blank. I'm just going to put furnace mate commissioned furnace. Do here is typically, if I had internet, but for some reason my data's poor, I would ping the address. So what we're going to do is we're going to profile the system first. This is a Lennox system, EL296. And when I want to take the serial number, this is perfect. I don't know if you can see this, but auto-populates. And then I just got to remember to remove the S that's put in there. And I take a photo of the reading plate. That's done. And then what I'll do is I'll profile the furnace. So we have a 90 furnace. is 50 to 80. And my static 0.8. So now that I got everything profiled, ECM motor, all that's done, submit. Everything should be loading up. So as you can see my gas pressure, my temperature rise is coming in. So now that it's profiled, I'm going to put everything together and let it run 5-10 minutes, see how everything's doing. Okay, so I captured my gas pressure currently at 3.59. And what I'm going to do now is I'm going to go outside and set my input. So I'm going to do a dial test, see where my input's at, then come back in, adjust my gas pressure, and then adjust everything else. Setting the input is by far one of the most important things you could do. Get your input right, get your temperatures right, temperature rise right, and long term, everything else should be fine. And then what we'll do is we'll come in and do a combustion test to make sure everything else is doing good. A little tip I do. See, I've unplugged this water tank so that it doesn't come on when I'm setting my input. And so that I don't forget to plug it back in, I put my car keys on there. Just a little tip. Alright guys. So what we're going to do now is check my input. By the time I'm done my input, that furnace should be at steady state. Okay. So, we're going to clock the meter here in Ottawa. I checked our local utility and the heat content of gas was around 1041. Okay, I'm going to pick the 0.01 dial, which is this one on the left, and I'm going to do 2 revolutions of that. So we're going to start it now. Basically, I'm going to watch this guy spin around twice. So we're just about to hit 1 rotation. So we've passed 1 rotation. Here comes our 2nd rotation. Right there. Clocked my input, which is actually pretty damn good right now. So I'm going to submit that. And in order for me to get that 66 input that the furnace is rated at, my target manifold... Alright, so we're back at the furnace. And as I dial it into 3.7, watch what happens to my input. The whole point of these input tests are if our input was incorrect, either too much or too less, you would order new orifices, because every place around North America has a different heat content of gas. So anyways, so let's dial this in, and I'll show you a little trick here. Okay, see how my pressure is falling? Now it's rising. Well, on these furnaces, when you adjust it, make sure to put your finger back on it, simulating that the cap's on, because the pressure changes. So technically my pressure is 3.58, so I'm going to go up 12 points. Look at my input, 3.68, 3.67, just shy of 66,000. I'm going to go a couple points above. 3.7 on the dot. See how it's just pressure is 3.7. So let's go inside and dial that gas valve in so that we get the proper input. 3.70, 66,000. That is by far one of the most important things you could do for this furnace. Okay? Okay. So, return static. Wow. What is going on there? That's ridiculous. That makes no sense. Got 0.2 on my supply, but look at how crazy my return is. 0.8. So let's see what's going on here. Smooth filter, as you can see, and my return side is still 0.5. Pretty damn high. It's time to investigate. Alright, so I'm going to go to my pressures. Pressure 0.96. So if we see here my static, I mean it's still in the green because we have a little bit of play, but not as good as we'd like to see it. So, and that's all returned. So perhaps we quote this guy some duct modifications. When I go upstairs, I'll make sure there's nothing restricting the ductwork, and we blocked returns or something along those lines. So if I look here, temporize, supply, everything's good. Picking up no CO, no gas leaks, visual inspection done. I'm going to capture my temperatures and I'm going to get ready for my combustion test. Loosen my test port, which I did. My analyzer's zeroing. Getting ready for combustion. Okay. I'm going to do a combustion test. Got everything connected. Start inputting my values in. Once I can afford a better combustion analyzer, like the Blue Flame, it'll automatically upload. Alright, so I have 22 parts per million. My O2 is 7.2. My stack is 107. Excess air is 52. Oops. 107. Combustion air is 37. CO air free, I have to do a calculation because my meter doesn't do it, but we'll do that after. My O2 currently is 7.8. 37 degrees outside. Right now my efficiency 93.6. Excess air was 52%, which is good. So there we are. So I'm going to input everything in, and then that'll show up over here once I figure out my air free. And everything seems to be dialed in really nice. At the same time, it will give me my airflow, which is pretty much bang on with what the ECM readout is. And the way we get that is once we got our input correctly and we got all our other metrics, it's able to calculate a value for estimated airflow. So, and lastly, take my electrical readings, okay, with the redfish meter, and I'll show you how that's done. So I'll go to my toolbox, I'll connect my meter. Now this is going to be hard with one hand, but we are clamped. As you can see, it's reading my combustion blower amps. I capture that. At the same time, I'll do my motor. Drawing 4.1 amps, which is pretty high for this motor, okay, and that's because of my static. If I take my total amp draw, we're about 4.8. I don't know if you guys can see that there. Typically, it should be lower on these. I think my static's affecting that. So another reason to correct static pressure is to reduce energy costs. So, once I'm done that, hook up my leads. Take my voltage readings. So we have incoming voltage. 119 will capture that. We'll head to my low voltage. 25.5, capture that. We'll do my polarity, which helps determine, you know, if I'm going to have good, because if your polarity is messed up, you're going to have some rectification issues, so you want to check that. So polarity on this one is in range, 93.8. So I got all my electrical readings, and if I wanted to, I could actually do my watts, and I'll show you how I get watts. A little bit hard on this furnace because I can't get into the blower door and put everything on with the redfish, but I'll give you an idea. If I clamp my main line, there we are, 290 watts, so I'll capture that. My power factor is 0.8. We'll submit that. And we got all our numbers. Basically at this point, I shut everything off, I clean it, show it to the customer, and I provide them a commissioning report, which will look something like this. Once I get outside, I'll have my internet, but it gives me all my metrics, fully commissioned, you know, rated input 66,000, meter input 65, looking really good, guys. Before I take off, I always check my errors on my board. Zero errors, so don't gotta delete the board history. So I'll basically wipe it down. This one's fairly clean. One thing I will look for is the return static's a little high. That'll go into my recommendations. Thanks for watching. Alright guys, so I'm all done with that one. Brand new install. We had high return static pressure. I think just on the return side was 0.8. Total external of 0.96. Rating plate asking for 0.8. Higher wattage usage than normal that I see on those units. Customer also complained of high velocity noise, and that's simply due to the lack of return. Sounds like a 747 taking off. So money is on the table for that one. Did recommend that we install a 5-inch filter cabinet with a 5-inch media filter, and also quoted in some duct modifications to add some return, which will help long term. I mean, the guy's got an expensive ECM V-blower in there, so we don't want the static chewing up through that. Also is, he's complaining about the noise, so let's fix it up and do what's right and fix the duct work on this home. Other than that, I just wanted to give you guys a good rundown of basically how I go about my commissioning of a furnace. I mean, it takes me about an hour. That one took a little bit just because I was digging through the house trying to find any blocked returns, anything that would lead to the high static, which I didn't. So simple ductwork fabrication will work for this guy. But you've got a good idea of how I use Measurequick, how I clock the meter. Getting the input correct is very key. Got the airflow correct, so my temperature rise was right on the middle. I mean, it was 60 something on a 50 to 80 rise, so certainly where that needs to be. Adjusted my manifold pressure to get correct input at 3.7. Combustion test results were nice and clean, nothing out of the norm, and other than that, that was it. So thanks for watching. Subscribe, comment down below, and we'll see you on the next one. Take it easy.